Hi everyone, I am going to walk you through a couple of sine and cosine functions and how to graph them. I'd like you to take notes as you take this video, as you watch this video, and pause as much as you want, but make sure you are understanding as you go. If you don't understand, please check in with a classmate. So the first one I'm going to do is 3 sine of x. So what you want to recognize, as you know, I always look at the sine function, and the sine function is always going to start at 0. So I know I'm going to start at 0. The transformation I see is this 3 out in front, and that is being multiplied and it's on the outside. So I know that that's going to affect the amplitude. That is a vertical stretch of 3. And that's actually the only transformation I see there. So a vertical stretch of 3 tells me that my amplitude is going to be 3. That's what's changing. The period doesn't change because there's no horizontal stretch or shrink, so the period's going to remain 2 pi. There's no phase shift. It doesn't shift left or right. There is no reflection. There's no negatives in there. And the midline didn't move up or down, so the midline is at y equals 0. That's where it normally is. If I draw in that midline, which I will do, my midline is the x-axis. I'm also going to draw in where my amplitude would be so I can see just with a dotted line what it's going to be between. This kind of helps me see my bounds for where my sine curve is going to go between. Now I'm going to plot my points. So I know that my first point is going to be at 0 because I have the sine function, and the sine function starts at 0 and goes up from there. I also know that my period is 2 pi. So I have a 0 at 0, and I'm going to go find my last 0 at 2 pi. For the sine function, I start with those two outer zeros, and I'm going to have a 0 between them. So that would be smack dab in the middle. I have a 0 at pi. I have a maximum between the first two zeros because it goes up after this first one. So there's a maximum between those. So at pi over 2, I have a max. And between the next two, I have a minimum. So at 3 pi over 2, I have a minimum. So between these 5 points, these are my core 5 points, I can create one period of that sine curve. Now from here, I can mimic this exact same thing on the next 2 pi. So I could have put my first zeros at 0, 2 pi, 4 pi, and negative 2 pi. Between each of those, I have zeros. So at every value of pi, I actually have a 0. Now between these two, I have a max. Then between these two, I have a min. Between these two, I would have a min. These two, I'd have a max. And I'm just going to keep going with my curve. So for the sine curve, you plot those 3 points first. The 3 zeros get plotted first. 1, 2, and then 3. Those are your first 3 points. Sine curve, first 3 points are your zeros. That's going to be different from the cosine curve. Okay, so there's our first sine curve. The only difference between that and the parent function is the fact that it has an amplitude of 3. So now I'm looking down at the next one. I also have a sine curve. It's going to start at 0. However, this one is going to move to the left pi, which is a phase shift. So I can write under the phase shift left pi. And it's going to go down 1. So that affects the midline. So my midline is at y equals negative 1. So again, I'm going to plot my midline first. Negative 1 is where my midline is. And the amplitude didn't change. Nothing affected it in the front. So the amplitude is going to be the normal 1. The period didn't change. Nothing was multiplied on the inside. So the period is 2 pi. And there's no negative multiplier, so there's no reflections. So that helps me to know, since my amplitude is 1, I can now put my bounds in of where the max and min are going to be. And those will be at 0 and -2 because I'm going 1 away from the midline. My first point is going to be at 0, but it's going to move left pi. So instead of starting at the midline here, I'm going to move left pi and start at the midline here. There's my starting point. So again, sine starts at 0 normally. However, it was shifted down 1. So here's where the midline was. And it was shifted left pi. So that's why my starting point is there now. Nothing about it changes its initial direction. So it's still going to start going up and to the right. The period is the same. So I can automatically see that after 2 pi, I'll have the same point. And since it's a sine curve, I plot those 2 points and smack dab between them, I find my middle 0. Between the first 2, I have a maximum. Second 2, I have a minimum. And there is my first period of that sine curve. So from here, I can continue going every 2 pi and creating that same exact situation. And then going the other way, this was going up here, so it would have to go down to this way. Not there. And there it is. So even though I'm writing start at 0, it's important to make note of the fact that you still have to look at where it's moving to see if that start point is starting at any different of a spot. And it's going to start at a different spot if the midline changes and there's a phase shift. All right, I'm going to do one more example problem, and the next one is a cosine problem. So sine starts at 0, cosine starts at 1. All right, the only transformation I see here is this 1/2 in the inside. So that is a horizontal, and that's a stretch because on the inside it happens opposite of what you expect. So that's a horizontal stretch by 2. So this is where it's kind of difficult. You have to figure out the period and you have to do some math for that. So the period is equal to 2 pi divided by the b value. So in this case, that's divided by 1/2. Dividing by 1/2, let's write it out like this. 2 pi divided by 1/2. That's going to make it a little bit nicer for you because then you can clearly see it's 2 pi times 2 over 1. So I know my period is then 4 pi. 4. That's the only thing that changes. So the normal amplitude is 1. The normal midline is y equals 0. There's no reflection and there's no phase shift. So I can see my midline at the x-axis and know that my amplitude is 1. So it's going to all be between -1 and 1. It says start at 1. So I'm going to start up at the top. That didn't change because it didn't move anywhere. So it didn't move anywhere, so that didn't change. And then I know my period is 4 pi. So after 4 pi, I get the exact same spot. And those are 2 maximums. Smack dab between 2 maximums is a minimum. There it is. between a max and a min is a 0. So between 0 and 2 pi is pi. So I've got a 0 there. And between 2 pi and 4 pi, I've got another 0, which is at 3 pi. In the sine curve, I plotted 3 zeros first. Here, I plot the two ends, which are either maxes or mins, and then the middle piece, which is the opposite of what the two ends are. Those are my first 3 points. It goes 1, 2, 3. So within each period, you go first point, last point, middle point, and then you find the two between there. So now I can use the same pattern going backwards. So I'll just finish this out with a curve. And I can see from here it has to go back down to a 0 and back down to a minimum. And there is my cosine curve. So cosine curve started with my two maximums. I found the minimum, and then I found the midway between those for my zeros. All right, so those are 3 examples. The really important thing is you recognize what your different transformations are, how they're affecting your graph. I would plot your midline first, then figure out where your amplitude is going, then figure out your starting point, and based on your period, find your end point of that first period. All right. Good luck with your assignment and do your best.